The title for this entry is called Analyzing and Sketching Graphs. So when we talk about graphs in this section, we're deviating from the X and Y table really, and talking about how certain graphs have a story. And you can either look at the graph and figure out what the story is, or you can be given a story, like in this example here, and have to make a graph, because there's a relationship there. And this is really just to kind of get you thinking about how to look at different graphs. So we're going to start with this one here. Now, before we actually start diving into the problem, it's important to be able to use vocabulary to describe these graphs. So in your packet you have this paper here, and you also have a little chart that shows you what words to use depending on what the graph looks like. This chart has all of the different vocabulary that we'll be using in this section. So if a part of your graph looks like this, it's kind of curved down, this is called decreasing at a decreasing rate. So it starts going down really fast, and then the amount it goes down starts to decrease. It kind of levels off. Increasing at an increasing rate, right? So imagine as a story like you're jogging, right? You're jogging slowly, this is your speed, slowly. And then all of a sudden you start jogging really fast. Right? Maybe a dog's chasing you or something. Increasing at a decreasing rate. It means you start doing something really fast and then you kind of slow down. Right? So maybe that person stopped chasing you and you slow down. Decreasing at an increasing rate. Can you imagine maybe you're in a car and the car is braking. Right? It's braking, so its speed is going down, and all of a sudden it brakes really hard. Maybe there's a car that cut that person off or something, so it slams on its brakes. So it decreases, but really fast, so it's increasing. And then a constant is when you have a line that does not curve, so decreasing at a constant rate. Right? Maybe you're jogging and you're slowing down, but you're slowing down at a constant rate, like you're going down the same amount every second, right? Or speeding up the same amount every second. So you're increasing, but at a constant rate. Right? So these lines look similar because we've been going over slope and slope-intercept form and all these different forms of equations. Well, the slope here for this one is constant, right? Between this point and this point, it's going to be the same between this one and this one. Here the slopes are all different. Right, the slope between here and here is going to be much larger than the slope between here and here. So that's really how you read the chart, and we're going to use these vocabulary terms as we start thinking about describing stories and analyzing graphs. So we have 3 different problems to do. What we're going to do is we're going to take this paper here and we're going to fold it back. Increase it along these edges so it's a book, and then once you have that book, you're going to cut along these dashed lines just up to the crease that you're going to make so that they open up and we can solve the problem on the inside with the question on the outside. Here we have our first example. So the graph here shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Describe how they are related at various points on the graph. So we're looking at this graph and we're looking at the line here that it creates, and the variables that they're using for this graph are the kind of X and the Y axes here. Like, what are they labeled as? So time and volume. So the variables that they're using are volume and time. So we're going to open it up, and that's going to be the first part of our answer. So if we try and kind of explain how they're related in each points of the graph, we've got this line that kind of goes up and then steady, up and then steady, up and then steady. Right? So what is happening in these three spots here. How can I describe that line? What's happening to the volume? Right? So I look at here at my chart. Just this section here, right, where it's a straight line, looks like this. It's increasing at a constant rate. So that volume is increasing. So that's the first kind of part that I want to say here when it says describe how they're related at various points. So at the three lines, right, the person is blowing air into the balloon at a constant rate. So we explained this section, this section, this section. But what about these sections here where time goes on, but the volume's not increasing? So how could you explain that? When you think about yourself maybe blowing up a balloon, what do you have to do every time you start blowing up a balloon, right? You blow air, and then you have to take a breath. Somehow you have to get more air into your system and then blow that air back into the balloon. So it's at these points where it does not increase that the person is taking a breath. So the person pauses to take a breath. Right? And then, right, we've got this last one, the person blows in and then it pops. So how do you describe this line here? So what I would do is it's still kind of a straight line. Okay, so it is constant and it's decreasing at a constant rate. It might be really fast, but that rate is consistent. So that's our last answer, is that on the fourth blow, because, right, 1, 2, 3, and then this would technically be number 4, the balloon pops. And loses volume. At a constant rate. So see how we can get all of this information just from looking at this graph? And so it kind of goes two ways. If you want to present someone with a whole lot of information in a neat way, you can take this story and make a graph, right? Condensing all that information in this graph. The other way it works is you can look at a graph and try and figure out what the story is. So we're going to do that both ways. In our second example, we're actually given a table and we're asked to say which of these graphs represents the table. In this example, we're shown a table of this situation. A band allowed fans to download its new video from its website. The table shows the number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown on the table? So let's look at the way that this is increasing, right? Because we have all of these vocab in our chart here that shows what a graph looks like, and it's all talking about rate, right? A decreasing rate, an increasing rate, a constant rate. So if we can find the rate that this is increasing, we can figure out which graph it's supposed to look like. For example, this one is increasing at a constant rate because it matches this one here. This one here, C, right, if I'm looking at which one that looks like, kind of looks like this one, increasing at a decreasing rate. So which one of these tables matches which one of these graphs? and how can I describe it? So let's look at the rate here. From day 1 to day 2, it started at 346, and then it went up 1,011. Right, it went up to here. So what was the increase from 346 to 1,011? Now, since it doesn't specifically ask for the rate for that increase, we can estimate. And we can say that this increase is going to be about 700. Right, positive 700. And then from day 2 to day 3, 1,011 all the way up to 3,455. Well, that's going to be an increase of about 2,400. And then here, a big jump between day 3 and day 4, that's going to be an increase of almost 7,000. So the rate in this case could be described as increasing, certainly, at an increasing rate. Right, it's increasing, so the total downloads is going up, but it's going up faster and faster as the day goes on. Kind of like watching a YouTube video that starts to go viral, right? Not a lot of people see it at first, but then more and more start seeing it, and then it gets widespread, and all of a sudden there's like millions of views. Okay, that's increasing at an increasing rate. So that, for our vocabulary, if we look at our chart here, increasing at an increasing rate, and that's going to be B. See how this one looks like this, going up like that. So B would be our answer for this one. For our last example, we're given this situation. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. So now we're given a story and we're asked to make a graph out of it. Like, what do we expect this graph to look like? What variables are we going to use? These are all the questions you have to ask yourself. So when we think about a rocket, a lot of times these real life situations of rockets and speed and all these different things, our x-coordinate is usually going to be time. In this case, things are happening very fast, so we're going to do time in seconds. And actually, since we don't have any numbers, we don't even want to put seconds. We're just going to put time. If it gave us specific numbers, then we probably want to put seconds or whatever. You know, if it's in minutes, use minutes, but it's not given that yet. Right? We're not given any information about specific numbers, so we can just say it's time. Now, height is going to be our y-axis. That's our dependent variable. Height. So my first section is going to be in green, and I want to look at this word problem and try and figure out where it starts. I'm talking about the model and trying to break that down into different sections that I can label. So right here it says a model rocket rises quickly and then slows to a stop as its fuel burns out. So a lot of things happening in that section. The first of which is that the model rocket rises quickly. So in green I'm going to show that with my line. I'm going to show that it's rising quickly. So it's rising quickly, and I would say a constant pace. When I think of a rocket, I don't think of it kind of going faster and faster and faster. I think of it as a constant rate as it goes up. So this is my rises quickly. And then what happens to the rocket? So it says, and then slows to a stop as its fuel burns out. So then slows to a stop. And how could I show that it's slowing to a stop? Well, it's going to kind of level off here, right? Slows to a stop. Okay. Then it begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. So again, a lot of stuff happening in that section, but the first of which is it begins to fall quickly. So fall quickly, I think of as kind of that. Now it doesn't fall quickly the whole way down, so I can't draw it, can't draw it the whole way down, but certainly right here it falls quickly. And then the parachute opens and it falls slowly back to Earth. So it's falling slowly now back to Earth. So as time goes on, there's that rocket. Rises quickly and starts to slow down because there's no fuel left. And it falls really fast and the parachute opens and goes slowly back to Earth. Okay, and that's how we break down that situation and represent it with different sections on a graph. Now that you have your final handout ready to go, really the only one we flipped open was this top one over here. But what you're going to do is glue the back. If you have glue bottles, just kind of a dot on each corner. That'll keep it down without kind of getting the back all wet. And then you're going to take your table and you can glue that one down right in this margin here. So you'll have a chart to look at so you can see what vocabulary to use when describing a situation. And then you'll have your examples here that you can flip open to review your notes. And that's it for analyzing and sketching graphs.